All right, good morning. Hope everyone's doing well.
Doing pretty well, Nick. How are you doing?
I'm doing pretty well. Thanks. All right. Let me talk about PA4. Let me make a quick run through the delete function, and then make some general comments on PA4, and then we will move on to PA5. So, do PA5 in a minute. So the delete function was where most people ran into issues, and let me just show you some sample delete code. So, the usual setup: pass the root node, pass, in this case, a name of a plate that we're using as the key, and return the new root node. You don't really need this check here, because the root should not be null, because you should only call delete if you actually know the plate is in the table, and if your tree is empty, then it can't contain, your plate. So this isn't really necessary. And the recursive part of the delete function is pretty straightforward. So if the plate is, lexicographically before the root node, then you want to delete from the left subtree. So call delete with the left subtree, take the return value from that, make that the new left subtree of root, return the original root. And similarly, if the plate you're deleting is on the right, then do the same thing, but delete from the right subtree, take the return from that, set that to be the root's new right subtree, and then return root. So the trickier part is when you're deleting the root of the tree. And this is fundamentally different from pretty much all the other recursive code we've written so far, which mostly made recursive calls and had a simple base case like return 0, return -1, return true, print out the root node, right? In this case, the base case does a lot of work, right? It does everything you need to do to delete the root. And so our algorithm was, come into the tree and find the largest node in the left subtree and make that the new root. And have that node's parent adopt that largest node's left subchild as its new right subchild. So that was our delete algorithm. So how do you break that into code? So there's one exception, which is where there is no left subtree. So if there's nothing here on the left, you can't do what I just described. There's nothing in the left subtree. You can't find the maximum value and make that the new root. So in this one case, you get to do something different, which is just change the root to the original root's right subchild. So if root left is null, set the new root equal to root right, free the root node, and then return the root node. Let's see, really bad frame lag. Let's see how my upload's doing. 9 minutes left on the upload. Well, that's popping along nicely. Yeah, okay. Well, so, I upload the section A video, but that says it will be done in about 8 minutes. So maybe it will improve after that. Or I could just be talking intermittently, maybe. All right. So if there's nothing to the left of the root, then we just change the root to be the right subtree's root. We free the original root, and we return that new root. So that's our one edge case. Assuming there is something to the left, we need to move into this left subtree and find the largest node. And there's one sort of edge case here, which is where there's nothing sitting to the right of that subtree's root. And in that case, this is the largest node. So it's not a different algorithm. We're still taking the largest node and making that the new root. But in this case, right, the largest node is simply the root of the left subtree. So that's handled here. Temp equals root left. That's the left subtree's root. If temp right is null, then temp should be the new root. Right? So we set temp right equal to root right. Temp left is already set to the left subchild. We free the root and we return temp. Otherwise, we're in this general case where we're starting from the root and we need to move down, find the largest node, and we need to know who its parent is so that we can have that parent adopt the largest node's left subchild. So here I did this with a little look ahead, right? So temp is starting off as the root of the left subtree, so I say, well, temp right is not null. In other words, while temp right is not the largest node, and I move temp to be temp right. So temp is always the parent of the node that we're checking to see if it's the largest. And when we exit this one line while loop, we know that temp is the parent of the largest node and temp right is the largest node. And now we just, put into code what we've been putting into words. So the return value, the new root, will be temp right. That's the largest node. Temp, the parent of the largest node, its right child is changed to the largest node's left child, right? So that's doing this adoption of the largest node's left subtree at the parent's right, so we don't lose anything. And then ret, which is the largest node, we set the right child and the left child to be the right and left children of the original root. We free the root, and then we return that largest node. And nothing is being modified as far as the values of the nodes. What's really happening is 14 is changing to adopt 16 on the right, and 18 is changing to pick up 10 on the left and pick up 40 on the right, and 20 is going away. And we're getting this weird, kidney bean shaped tree instead, right? But we're never doing something like copying, this value into the root or something like that. We're playing with pointers. That's most of what we do with structures in this course. We just move pointers around. All right, so general comments on PA4. PA4 looked really good. Okay, the deletion is clearly the trickiest part, and we talked about this along the way, leaving it for last and so on and so forth. But deletion is tricky. And it's a whole separate problem in itself. But aside from that, most of the code I saw in people's submissions was good. It was solid, it was clean, it was well thought out. It conveyed a good understanding of the concepts here. Nonetheless, there were a lot of low grades. The average was around 50 something, and a lot of the point losses were avoidable, I think. And a number of the grades would have been lower if I hadn't decided to grade forgivingly in some cases. Let's see, I think I made a mistake where I made the left side greater, but I sorted based on that. Interesting. If you made the left side greater and the right side smaller, I'm not sure why your LNR would have come out correct.
I think I flipped my LNR to actually print out greater and lesser.
Interesting. Well. Okay, long as you know that that's what happened and you know how to do it the right way, you're probably okay. And I'm not going to go back and take off points. But yeah. Generally, when we do a BST, more often than not, it's smaller on the left, larger on the right. Um, but you could be in that parallel universe with the Earth on the opposite side of the sun, where LNR is done right side first, and effectively it will come out the same. Cool. Yeah, let me know if you don't find it. String compare is toast butter side down. String compare is a tricky function, because you list two strings, so argument 1, argument 2, and it's negative if argument 1 is less than argument 2. It probably took me like 15 years to make peace with that, where I don't have to like keep looking it up in the manual page. Toast butter side down. Oh, I thought it was the buttered cat paradox. Dr. Seuss. I don't know that one. All right. So general comments on PA4. Things that cost points, right? Or could have cost points. Oh, the bitter butter battle. Betty Binter's bitter batter needed better butter. Put your name in your code. A lot of people did not put their name in the code, and I don't know why. Because you've been doing this, but you don't need an assignment to say, make sure you include your name in the code. Always put your name in there, right? Unless you're doing this anonymously for some reason, or you've been told, not to. Put your name in there, right? This is your work of creative authorship. Have your name in there. Put in the class. Put in the date. Put in the assignment. Put in the synopsis of the program. Whether or not you see point deductions for it. Name your program correctly. The rubric said, name your program plate. And a lot of people didn't. They called it other things. Now, there was nothing in the rubric which said if you don't name your program correctly, you're going to lose 5 points. So I didn't take off points for that. But you should not need to see that in the rubric, right? And in general, going forward, you won't see that in the rubric. But here's what's going to happen. I told this to the last section, too. So it's going to sound like I'm just telling stories. But, there's a good chance at a university that you're in a class, with 80 students, and your assignments are being graded by a TA who's, TAing for multiple classes for a few bucks, and they've got, 300 programs to grade over the weekend in addition to doing their own coursework. They're going to take the shortest path possible through that, which means if they try to run your program, they say plate and it says file not found, they're going to write a 0 and move on. They're not even going to look to see if you named it something else, right? They're not going to go and they're going to say, oh, you named this thing PA4, and they're going to rename it to plate and then test it, right? Same thing with compile errors. A lot of people's code would not compile because, someone added a comment at the last minute, and instead of saying, // they got a space in between. And that will confuse the compiler. And so I would download someone's repo and I'd say make, and I get 10,000 compile errors. Again, if this is going through an automatic grader or something like that, that's a 0. End of conversation, right? I consider our time here at Clark to be, an educational process, and part of the education is working on these assignments and learning how to do trees and data structures and memory allocation, all that kind of stuff. And I know people have been putting in time, and I want to see what you did, and I want to give you a grade based on that. So I spent a good part of the weekend basically debugging people's code, right? Saying, oh, you've got an extra space in your comment, or oh, you called your function insert instead of add. Here, let me go in and change the 500 references to insert to add so that it compiles with your function, right? So that I could run your program and say, oh, your balance works great, your height works great, your search works great, right, and give you a grade. So it was a hefty penalty for not compiling. It's 40 points, right? That was in the rubric. But, chances are, beyond Clark, right, if your code doesn't compile, it's probably a 0. If it's not named right. it's probably a 0. If you run it in a seg fault, it's probably a 0, right? So even if you don't see something, with particular point values next to it, um, be thinking in terms of, I have one shot at impressing somebody to give me an A on this assignment, right? Um, so make sure you know when assignments are due. Make sure they're turned in by the deadline, right? You're not going to be able to go to a professor and say, "Oh, I thought it was due at noon, not 8." You know, it's probably a 0. So pay attention to that stuff. Pay attention to the stuff that's in the assignment prompt. Um, Put your name on the stuff. When you're done submitting, pull down a copy of your repo, say make, and run your test cases. Right? That's the acid test. That's what I'm going to do. I'm going to clone your repo. I'm going to say make. I'm going to run some test cases. So mimic that experience. Make sure that gets you, the output that you were expecting. And other things, right? So keep commenting your code. Keep indenting your code. I'm not putting, a function name requirement for a comment block on PA5. I'm not taking off points for indenting. I'm not taking off points for insufficient commenting. I want you to find your own sweet spot for that, right? Please don't go back to putting in left justified code with no comments anywhere, right? Because this is not for me. This is for you. This is for your future coursework. And I can guarantee at WSU, if you turn in code that's left justified with no comments, you probably won't get a grade, right? So keep up the good habits. Keep working on them. Work towards better habits. Whether or not, there's point deductions listed for them. All right. So that's the general stuff. All of that aside, right? PA4 looked good. There were low grades, but the code that people did turn in that I was able to run by and large looked good. So it feels like, allocating memory at runtime, building data structures in dynamic memory, dealing with the business of, my variable is always named the same thing, but it refers to different copies of that variable because I'm allocating these at runtime, right? That's a key concept. And that seems to be working for people. And the whole business of recursion, right, which is what almost all of this code was, that seems to be working pretty well for people. So that's all good progress, and keep moving in that direction. And that's going to take us into PA5. So any questions or follow up on PA4 first? I posted lots of feedback. Take a look at that on Canvas. Let me know if you have questions or concerns.
I just had a quick question about how you like to format stuff. So when you're commenting on the initial part of a function, when you're putting your name, do you just put that right at the top? Do you put it at the bottom? Do you put it on every single function that you've ever built? Like, just a good habit, or?
So when I'm writing a main program, I'll usually put in at least my initials. If this is something that's strictly going to be my own thing, then I might not even do that, right? I'm not going to pretend that I always comment my code and that I have all these amazing habits. That's just not the case. But let me see. This is probably dangerous. Right? So this is some code I'm going to push out to GitLab today, or this week, and put in the public domain. So I've got my initials in there. I've got a date that I was working on this, and not a whole lot else, right? Because I don't want to make this about me basically. But I've got something in there, right, just to allocate it to myself. And I've got some defines, and I've got explanations of what each of these things are, because I'm going to use these symbols throughout my code, right? So it's pretty important for me to have in one place, what these things are, as well as additional comments, right? Like this thing should be kept high except when I'm writing to the data bus, right? Which means something to me. And these things are, I've got one comment in the beginning for what these are, and then I don't have comments next to each of these. But I've described what this block of defines are. And then, and this is just a big monolithic, 2,000 line file. But I've got some comments in here. So here's my single step function, and I've got a big block here about danger, watch out for this, and what we're trying to do. And not every single line is commented. Right, I'm checking to see if this is true, and if it is, I'm going to toggle the clock while I say do tick 1. That toggles the clock. So and show data after step. Well, I put a comment here to say where we are. I don't have a comment block in the beginning. I don't say it doesn't take arguments. So this is mainly for me, and the level of commenting is something that you'll figure out, and it depends on the context. It depends how long this is going to be around, how complex it's going to be, and so on and so forth. And you'll discover it over time, right? You'll write some code and you won't put in a lot of comments, and you'll go back to it a year later, and you'll be like, I have to rewrite this because I don't know how to use this code I wrote. And so, that will move you towards, a heavier coding, commenting style down the road. Or you'll be in a rush one night and you won't bother putting in any comments, and the sun will rise in the morning and you'll be like, well, that worked out okay. So it's there's no hard and fast rule. But C code, I'll have a lot of comments generally throughout my code. At least on the particular lines, and sometimes before something happens. Stuff that's doing a lot of parsing and things like that, it's going to be sparser. So yeah, I don't know if that answers it or not. Let's see, I was having an issue trying to debug with GDB. I actually couldn't debug past the if statement. I was checking for the database existed. Oh, so when you use GDB, right, when you say run, instead of just saying run, say run and list your arguments on the run command inside GDB. So if you say GDB plate database name, it ignores those command line arguments. Those are arguments for GDB. But once you're in GDB, you can say run space and then list the name of the database file, for example, and that will go ahead and pick that up in your argc argv. Output format was different in the sample program from the instructions. Instructions had 2 more spaces than the sample. Yeah, we talked about that. No, you should not have gotten marked down for that. But if you lost points for formatting, it was almost certainly something different from that. So shoot me an email and I can tell you what happened. I did not take off for spacing. What should we not do on our SLP final upload? You should fill in that template from Canvas, and you should put in your name and the name of your project, and fill in all of the sections that you can. Remove the sections that you're not going to fill in. Don't leave the bullet points like AAA, BBB. But basically just describe your project, describe what you've done so far, describe your future plans. So it's kind of a touch point of where you are in your SLP. For the SLP presentation, how much info do we need to include? Are you talking about the actual presentation next week? It's up to you. The submission today is just a 1-page poster from that template, so there's not a lot of space. But yeah, for the presentation, it's totally up to you. Whatever you think you want to do to describe. Yeah, so that could include code samples, or you can keep it higher level than that. It's your choice. And, if people are in the room listening, they might ask you questions, and that might, change what you talk about and how you talk about it. Let's see, would I get marked down if I had debug print statements in one of my functions? Yeah, that would cost you, I think, 10 points for output issues. Should that only be a deduction for the incomplete function? I don't know. Send me an email and I'll double check. I think I looked at that actually. I think I remember the extra output in your delete function, and then I thought I saw something else. Anyway, send me an email and we'll look at it. Because no, if your delete function was printing out debugs, and that was the only output issue, I wouldn't take off points for that. So shoot me a note. On the topic of SLP, could you define what it meant by competitive analysis? You know, assuming that you haven't come up with an idea that nobody else has ever done or thought of, there's probably similar things out there, right? So just kind of, you know, when you're figuring out what to do and what the scope is and your milestones back in the beginning, one of the things that you could be looking at is, you know, what else is out there? What are the other solutions? And how do you compare and contrast to that, basically? So, you know, you can touch on that. If that doesn't apply, you can take that section out, put something else in there. But, cool. You're welcome. Var equals value. I never like seeing something like this without spaces, but it seems pretty common. You mean spaces are on the equal sign? There was a good Discord comment on that. Someone posted a few weeks ago. All right, other questions? All right, let's talk about the knapsack problem. So this is the essence of programming assignment 5. PA5 is not going to be. Yeah, somebody else said they saw 2 finals. The final is look at Clark's exam schedule, but it should be what's posted on Canvas, which should be, I believe, Wednesday, 11 o'clock. But someone else said they saw 2 times listed, and I don't know where that is. Is that on Canvas that you saw that? Canvas disabled my ability to do a student view. So I don't seem to be able to see what people are. So this should be the only thing that's visible. Is your final exam, March 17th. Unless you're looking under assignments. Oh, under grades. Oh, yeah, okay. Well, I'll have to get rid of that. Yeah, your final exam is on Wednesday, so follow the regular Clark final exam schedule. Yeah, thanks. I'll clean that up. I kind of thought if it wasn't visible on that main page, it wouldn't be visible, but I guess it's still there as an assignment. All right, knapsack problem. So, the basic setup is, you know, you're the millionth customer at a store, and so you've won a prize, and the prize is, you know, the manager hands you a bag, and you're allowed to fill this bag with as much stuff as you can fit, and whatever you can put in the bag, you get to keep. Okay, so it's one of these, you know, publicity events, and the bag is limited by weight. All right, so it can hold, say, you know, 100 pounds worth of stuff. And the question is, if you know the value of each item in the store, and you have an unlimited number of each item, what should you put in your bag to get the maximum value so that you can go home and sell it on eBay, right? So you go for the gift cards, obviously, because per pound, right, a $500 Visa gift card is going to be your best bet. But let's suppose it's a store that doesn't have gift cards, right? So you're given an inventory or an item list, and this is kind of a weak store, right? So it's got the following items. It has a pen, which costs $2 and weighs 1 ounce. And it's got a book which costs $13 and weighs 4 ounces. And it's got a I don't know what candy bar. Which costs $9 and weighs 3 ounces. I don't know what kind of candy bar that is, but it came with numbers that worked. Oh yeah, gift cards need to be activated. That's a bummer. Graphics cards, that would be a good one. Grab all the graphics cards. Alright, this store only has pens, books, and candy bars. And they've got really strange prices for these things. But, you know, it's a weird store. Alright, so the question is, if you have a bag of a certain capacity, how many of each item should you take in order to get the maximum value out of your bag? Do libraries have candy bars? I gotta go to your library. Now, there's a number of ways to do this. So there's a general class of algorithms called greedy algorithms. Greedy algorithms are algorithms that can be solved by solving the problem as far as you can at each moment, right? So a greedy algorithm would say, let's get the most value out of our bag to begin with. And so we could look at value per ounce. And the pen is worth $2 an ounce, the book is worth $3.25 an ounce, and the candy bar is worth $3 an ounce. And so the most valuable item in the store is the book. So start taking books. Book. Wow, I had no idea I could have been eating lunch at the Clark Library all those years. But it's not a problem that lends itself to a greedy algorithm. And the reason is, this is called the integer knapsack problem. You have to take a whole number of items. You can't take, 1.5 books, for example. And so here's a situation. Suppose your capacity is 6 ounces. Well, since the book is the most valuable item, we would say, let's take one book, and that's worth $13, and that's, weighs 4 ounces. Well, we've still got 2 ounces left. We could fit 2 pens, so let's do 2 pens, and that's worth a total of $4 for 2 ounces, and we've got $17. So yeah, we could take as many books and then as many candy bars and so on. And we can divide by price per ounce and rank them. But this is not our optimal solution. There's a better solution to this problem. So what's the better solution? Can I get more than $17 into this bag? $18. I can get 2 candy bars. $6 ounces, $18. And candy bars are not the most valuable item. They're only worth $3 an ounce. But because we're not allowed to take fractional amounts of things, right, if we could take 1.5 books, this would be the best solution. But once we take a book, we've diminished our capacity by 4, and we can't fit this candy bar, which turns out to be worth a whole lot more than the pen. So we need a non-greedy approach to solving this problem. And it's going to be a recursive algorithm. And this is a little strange. This will be a different kind of algorithm from most of what we've encountered so far. But it's an example of an algorithm that we'll see more and more. And we'll do multiple examples this week of different problems like the knapsack problem that all let us write a recursive function to find the solution. So let's just start with the knapsack problem. And here's our item list. And so let me put these things into some arrays. So I'm going to call this value, and I'm going to call this weight. And we're going to define a function. And this is going to be called maxval. And maxval is a function. We feed it an integer, and it returns the maximum value for a bag with a given capacity. So if we call maxval 6, it should come back with 18. And we definitely don't want to just try all possible combinations of all items, because that's going to be really computationally expensive. But it turns out we can write this maxval function really, really simply. When we code it, it's going to be basically one for loop. But let me write some pseudocode. And here's the idea. We don't know what combination of items will give us the maximum value. But we know that we're going to start by putting some item into our bag. Now, we don't know if it's this item, this, or this, but whatever our maximum value is, we're going to get that by first picking one of these items and putting it into our bag. Agreed? Because if we're going to have anything in our bag, there's got to be a first item we're going to put in. Now, I don't know if it's going to be a pen or a book or a candy bar. But it's going to be one of those. So let's just see what happens in each of those 3 cases. Suppose I start by putting a pen into my bag. Okay, 2 things have just happened. Number 1, my bag contains $2 worth of stuff, the value of a pen. Number 2, my bag can now hold 1 ounce less. It used to be able to hold some capacity, now it holds capacity minus 1. So what's the maximum value I can get from my original bag now? It's the value of the item I just put in 2, plus whatever the maximum value is that I can get from a bag whose capacity has been diminished by 1 ounce. Now that's one possibility. Second possibility is I put a book into my bag, in which case I get $13 out for the value of the book, plus whatever the maximum value is I can get from a bag with my original capacity diminished by 4 ounces. And the third possibility is I start by putting in a candy bar, and now the capacity of my bag has been diminished by 3. And so if I find the maximum value I can get out of that bag and I add the value of the candy bar, that's the best I can do if I start with a candy bar. Since I'm starting with either a pen or a book or a candy bar, one of these 3 values will be my max val of capacity. So calculate each of these 3 and return the largest, and you're done. So this is in some ways a really, really simple function. Conceptually, right? It's a very simple idea. Go through every item, calculate the value of that item plus the maximum value of your bag when you diminish its holding capacity by the weight of that item, and just take the largest of those. With a few caveats. There's always some details, right? So the first detail is don't consider any case where the weight is bigger than the capacity. If the capacity of my bag is only 1 ounce, I'm not allowed to consider the possibility of starting off by putting a book in, because a book weighs 4 ounces. And this would say, you know, if I put a book in, I can get $13 plus whatever I can get out of a bag with a capacity of -3 ounces, and that doesn't make sense. So we don't want to consider any of these cases. And we also need a base case, which is if the capacity is equal to 0, return 0. We should not call this when the capacity is negative. That's what this is going to take care of. But if we check when capacity is 0, meaning that we've used up the whole capacity of the bag, then we should just return a 0. This does not actually check all of them. There can be cases where, depending on your combination of weights, there may be values that you don't actually check. And there may be combinations you don't go through. Well, no, you should end up going through all the combinations. But we're going to be able to code this in a way that's going to make it a lot faster than just kind of exhaustively going through all possible combos. All right, so does this make sense so far? So let me do a few specific examples. And let me call my function MV. So the max value of a bag that can hold 6 ounces will be the largest of the following 3 values. If we start with a pen, that gives us $2, and it takes away 1 ounce from our holding capacity, so it's $2 plus max val of 5. If we start with a book, that's $13, and it weighs 4 ounces, so we're left with 2. And if we begin with a candy bar, that's $9, and it weighs 3 ounces, so we're left with a holding capacity of 3. And so when I call my max val function and ask for max val of 6, it's going to have to call max val for 5, 2, and 3. And max val 5 will be the maximum of, star with a pen is 2 plus max val of 4. Star with a book is 13 plus max val of 1. And star with a candy bar, it's 9 plus max val of 2. And so on. Now there's 2 complications to this. The first complication is this is going to be really slow. And we'll see why tomorrow. But we're going to have to speed this up, and we're going to learn something called dynamic programming, which is basically building a cache for recursive function values. And that will speed this up significantly. The second complication is that when we're done, we don't just want to know what the maximum value is, 18. We also want to know how do we get that. We want to know 18, which you get by taking 2 candy bars. So we're going to need to keep track of additional information. So programming assignment 5 is posted. We've only got 5 minutes, so we can't get through all of this, but let me hit the highlights for you, and then we'll go through it more tomorrow. So you're writing a program called knapsack, and it runs with 2 arguments. Okay, the capacity of the bag, and the name of an inventory file or an item file. Okay, your item file looks like this. It's the name of an item, a value, and a weight. And there's simplifying assumptions. You can assume this is 32 characters, it has no spaces, etc., etc. All right. So you run your program, you say knapsack, the capacity of the bag, and the name of an inventory file, and it should solve this problem and find the maximum value that you can get out of the bag and the collection of items that you use and how many of each item in order to get that maximum value. Okay, we're going to talk about dynamic programs so that this runs in something, reasonable time-wise. And I want your output to be something like this. Now, I'm not going to be nitty-gritty about output, but I would like you to do the following. Show the contents of your inventory file, right? That's just to make it easier to see if your program's doing the right thing. Repeat what the bag's capacity is. Show what the highest possible value is, and then show the inventory of items that get you that value. And there's a sample executable, temp knapsack, and there's a sample item file, knapsack.data. And so you can play with those. Obvious error checking, too many arguments, too few arguments, not a valid integer, things that aren't integers in the item file, all of that kind of stuff. Typo in the submission, but I'm going to stick with it. Call your repo knappack. Okay? It's a spelling error, but we're going with what's in here, so I don't have to change it. So that's the name of your Git repo. Again, if you want to make your repo before noon tomorrow, send me an email to my regular Clark email and ask me if I can download, and I will try to download. Grading is pretty straightforward, so this has to be available for download by next Monday at 8 a.m., no exceptions. Okay? If I can't download your repo, it's a 0, I'm sorry. But I can't take late assignments because that's our last week of class. And things just get really tight. If it doesn't compile, 50 points off. If I get warnings, 10. If it's seg faults, 50. If it does not find a solution, 50. If it finds a solution but it's not optimal, you lose 30 at least. If you don't implement dynamic programming so that it actually finishes running, that's 30 points. And if it doesn't show the inventory of items that get you the maximum value, or if it's incorrect, that's 15. This program, when it works, you'll know it works, right? You'll be able to run it on a file, and it will come back quickly, and it will give you the result. And you can run it against test cases, and you'll get the same result as the sample code. There's not a lot of wiggle room. You do not need to include a data file in your repo. I'll be using my own. There will not be any particular extreme cases where I'm stress testing, but I might do an item file with 100 things in it, which if you're not doing dynamic programming means your program will never finish, and or it will crash the machine from a Stack Overflow. This is in some ways a lot easier than PA4. The algorithm is simple. I mean, your max val function, which is really the guts of it, is really, one for loop with, a running maximum where you, initialize your largest value to say this first thing, and then you just loop through the others and compare. But there's a lot of details to making this work, especially keeping track of the items that get you the maximum value. But I would code this up as just a max val that takes an integer, returns an integer first. And then you're going to have to think about, well, I need to do more than just return the maximum value. I also need to return somehow the information about what list of items in what quantities got me that value. So you're going to want to define some kind of structure that you can pass back from max val and that you can eventually save and compare in other calls. And we'll dig into that a little more tomorrow also when we go through more examples of this. But that's the basic setup, okay? You can read through this and we'll go through this more tomorrow. We'll go through more examples of this. And then we're going to work on some other problems, cutting up rods, dropping eggs off buildings, all kinds of things that will be similar to this, where we can define a function that's recursive that gets us our solution to the problem. All right, cool. Have a good one. I will see you next time.